The 50,000 token per second limit. Groq's LPU-v3 just sustained 50,000 tokens per second across a single LPX rack, achieving this not through higher clock speeds, but by treating the entire model as a hardwired logic circuit. While the industry fixates on memory capacity, this architecture minimizes the memory wall by keeping every parameter on chip in ultra-fast SRAM. This changes the fundamental math of real-time inference, and the architecture of that silicon is where the real deviation begins. Why SRAM beats HBM for decoding. The LPU-v3 skips the high bandwidth memory typical of GPUs, opting instead for 500 megabytes of local SRAM with 150 terabytes per second of bandwidth. Think of it as a difference between a library and a whiteboard, where NVIDIA's Blackwell must fetch data from a separate memory stack. Groq's data is already where the computation happens. This software-defined scheduling allows for a deterministic data flow, meaning the chip knows exactly when and where every token will be processed before it even starts. This total lack of jitter is why the system stays efficient even as context windows grow, but that speed comes with a significant physical footprint compared to a single GPU. The 20x advantage over Blackwell. Direct benchmarks against NVIDIA's Blackwell B200 show a 20-fold advantage in decoding speed, primarily because Blackwell is still bound by the physics of off-chip memory access. While a B200 might offer superior TFLOPS for training, those cycles go to waste during inference when the processor is stuck waiting for the weight matrix to load from external memory. The LPU-v3 trades that raw compute power for immediate availability, delivering a time to first token that is virtually instantaneous. However, there is a clear penalty. The limited SRAM density means you need an entire rack of 256 LPUs just to fit a 70 billion parameter model, a cost per parameter trade-off that NVIDIA's HBM approach avoids. This massive hardware footprint is the overhead required for sub-millisecond response times. This trade-off defines the new boundary of what agents can do. The real implication. The shift toward Groq's architecture signals that the industry is splitting between training-heavy GPUs and inference-first logic circuits. By prioritizing bandwidth over capacity as seen in the SRAM specs, the LPU-v3 enables a class of agentic AI that can perform 50 sequential reasoning steps in the time a standard GPU takes to finish one. This does not just make chat faster, it makes recursive self-correction and complex multi-agent loops computationally viable for the first time. For developers, the takeaway is clear. The hardware bottleneck is moving from the processor to the interconnect. As we move into 2027, the real indicator of a platform's value will not be how many gigabytes of VRAM it has, but how much of that memory is living directly on the silicon die. Watch for the first production-ready Llama 4 agents running entirely on these LPU clusters to see if the latency-to-revenue ratio actually justifies the rack space. Subscribe for more.